All right, hello and welcome everyone. Thank you for choosing my session. You've had a lot of really awesome sessions going on during this event, and I'm really humbled and grateful that you chose mine. So, without further ado, let's talk about what PASS has to offer. Local user groups and SQL Saturdays were really where I got my start. It's the reason that I'm here today speaking to all of you, if I'm being honest. You know, my first user group was the Rhode Island SQL Server users group, and it was also the first place I ever did public speaking. Uh, Also, SQL Saturdays, they're like mini one-day summits, right? You come in, you give up a Saturday to learn, to network, and you've got all these great sessions running a variety of topics to choose from. Really, if you haven't been to one of those, I would highly encourage you to. Plus, Pass has Pass Marathon, back-to-back webinars with a theme that kind of ties them all together. And also the virtual groups. There's tons of virtual groups. And to be honest, local groups right now are set up similarly to virtual groups. The difference is the virtual groups usually focus on a specific topic and the surrounding areas. Also, local user groups are people from your local community, just like you'd find at the SQL Saturdays, etc. Please also consider getting involved. This is extremely important. Events can't happen without help. Whether that's, a SQL Saturday, which needs people to help plan the event, or even day of. I can't tell you how important room monitors are. They're amazing. I've run several SQL Saturdays, and I couldn't have done any of that without help. Now, session evaluations are near and dear to my heart. I do actually read every piece of feedback I get. So my hope is that you will submit that feedback, and please do so before Friday, November 20th at 5 p.m. Eastern Time, US. The reason is you'll be able to win prizes if you do. Now, we all love free stuff, so who's really going to turn that down, right? Little bit about me before we start getting into things like our agenda. My name is Brandon Leach. I am a Microsoft Data Platform MVP and have been working in technology for over 15 years. My focus has been on automating large-scale environments, both scale up and scale out. I am very big on automation, and I hope that comes through in this presentation. My contact info is listed here. You can reach me on LinkedIn, Twitter, or just email me with questions you have. And let's talk about our agenda for today. So anytime we talk about automating infrastructure, our builds and configurations, we really have to talk about this thing called infrastructure as code. It's a philosophy, etc., with some core principles designed to solve a couple different problems that we'll actually go over in a moment. As part of that, we're also going to talk about infrastructure automation models. What is declarative as opposed to the imperative model? Once we're done with that, we'll actually dig into Powershell Desired State Config, or DSC. Starting with a brief overview, then moving on to a quick discussion of the Local Configuration Manager, or the LCM as it's known. We'll talk about configuration definitions and resources. Now, here I will say that Infrastructure as code refers to these things as definitions. What a server should look like. PowerShell calls these things configurations. I prefer to use definitions, so I'm going to try to stick to that convention throughout this session. We'll also talk about pull servers briefly. We're not really going to get into setting up a pull server during the session. There's just only so much that we can really fit into a hour here. So I want to make sure that we use the time efficiently. And we're actually going to go about setting up an availability group with desired state configuration. It's going to be really cool, really awesome. And I really, really hope you enjoy. All right, so let's talk about infrastructure as code. In order to talk about that, we need to talk about the problems that it's designed to solve. If we look at builds, how many times have we gone to do a build and found that our documentation, our checklist of items to do was missing a step, right? Or how many times have we just missed a step because we're human? Humans make mistakes, right? Robots do exactly what you tell them to do every time. And so if the robot makes a mistake, then that's due to us not taking something into account. So if we automate our builds properly, we can avoid mistakes. Another problem comes from what's called configuration drift. This is when the actual configuration of a system is not what was expected. Anyone ever had the problem of someone coming in and making a change that they shouldn't have, right? So I've had that take down production environments. When certain people who weren't DBAs had access and they just went and made that change. Now, obviously, as a DBA, I would argue against them having access unless they actually need it. But sometimes you get overridden, right? Also, what happens if the server just crashes and burns and you can't recover it at all, and you need to rebuild it from scratch? Well, that customization can be lost, right? That drift that was put in place there for a reason, for a good reason, but which wasn't brought back into the build documentation, it's gone. So unless you're reaching out to your servers every day and pulling all the configuration values for your systems, if things aren't properly automated and documented, you're in trouble, basically. So by automating this stuff, we can actually go and we can make our lives easier. So infrastructure as code has some core principles. Specifically, if we're doing a top to bottom here, the idea behind infrastructure as code is that deployment and management of your infrastructure should be automated. There should be as little human intervention in the process as possible, right? Your job should be to work on the robot and let the robot work on your infrastructure. Right? It's a completely different way of looking at our infrastructure. Additionally, we want to keep our system simple. In that I mean, small independent modular services. Like, for example, if you are using SSIS, right? SSIS should really be its own server, right? Yeah, it may need a tiny SQL server underneath it, but you limit the memory on that, and you make sure that the focus is entirely SSIS as much as possible. And this is opposed to just installing SSIS on your main production system. Don't run your packages from the same place as your main core databases. It's just going to cause you issues at some point, since SSIS does not use the same memory space as SQL Server. They're really different things. There's also the concept of convergence. And what I mean by convergence is that a system should manage itself. It should determine if it's in compliance and rectify itself if it's not. Right? So someone goes and changes a setting. Well, as soon as the server audits itself, it sees it's out of state, it should change that setting back to what it expects. This helps us reduce that configuration drift and keep things in line with what we expect. It also means that our definitions become kind of our source of truth. They become critical to our environment. There's also the concept of declaration / abstraction. And this one does kind of require a little more discussion. So we're actually going to touch on that one in a little bit. We're not going to touch on it just yet. So when we talk about infrastructure as code, it's important to understand the life cycle, right? So what you'll see here is very similar to what your development teams use, right? They plan, they design, they develop, they test, deploy, support, and the whole thing starts over again. So, when we talk about definitions, these are source code essentially, right? They're scripts. We can store those in source control. And we can actually, as a result, use deployment tools like Octopus Deploy, Jenkins, etc. to automate. So say, for example, I want to make a change to a SQL Server configuration. I go and update the definition in my local branch. I then, submit a pull request to merge that into development. Once that's approved, it's merged in, and a tool, like I mentioned, detects that because it monitors source control. And it goes and, in our case, in a desired state configuration case, goes and pushes that out to the appropriate systems. So this allows us, it'll do that by, putting it on what's called a pull server that we'll get to down the line. But in that sense, all those servers that are looking at that pull server will actually find themselves, hey, we've got an update, let's apply it, and they will apply that update. Then we can do the same process for test after it's been vetted in development, and we can just continuously move it up the chain, merging it into higher level environments as we go and letting the automation do the work for us. Now, this is really cool. To get to that point really requires a a willingness to learn to do things in a different way, to actually take some lessons from your developers. If you want to go the infrastructure as code route, I absolutely recommend that you have discussions with people on the development side, because they're dealing with things like continuous integration and continuous deployment all the time. They'll have some best practices around that, more than we have time for right now. A great use case for this, by the way, is Sql patching, right? So you've got, say, 200 servers in your environment, and a giant chunk of those are, dev. So you create a definition for your development systems. And once you have that, right, you put that definition on a pull server. Boom, you can push out a Sql patch using the package resource, and it will start installing that on all of your development machines, and just your development machines. Then when you're ready for a higher level environment like test, staging, whatever, you can then push that that definition to the appropriate pull server for that environment, and now you're good. Now you're moving it up through your environments. But because this is also stored in source control, these definitions, there's another benefit, and that is that you can actually go back in time and look at the state of your systems, way back when, which is kind of cool. You can see where you made certain changes. All right, so when we talk about infrastructure automation, there's two things that we really need to, or two models we really need to discuss. And that's kind of the imperative versus the declarative. So when I was much younger and first finding myself having to manage multiple systems as the sole DBA, desired state config wasn't a thing. These, declarative tools weren't really something I was aware of. So, and at the time, PowerShell was still kind of new. But even before that, managing SQL servers, I was finding myself, originally writing code in C# to allow me to automate tasks across servers and systems, etc. So in an imperative model, I had to tell the robot exact steps. I had to check for conditions and, based on those conditions, have it call other scripts that did different actions. And while it was super, super flexible, it was very complicated. Hunting down an issue could take a long time, unfortunately. It was really time consuming to build all of this as well. But then, we started getting these declarative tools. And these were really cool, because now instead of telling the robot what we wanted, instead of telling the robot exactly how to do it, we could take a page from the query optimizer and just simply tell it what we want. When you write a SQL statement, you're not telling SQL Server how to use your, or how to satisfy that query. You're not telling it to use this index, use a table spool here, use a hash merge there, or a hash join, there, right? You specify the data you want, and SQL Server goes out and builds a plan to get you that data that it executes. When we talk about the declarative model in infrastructure as code, that's essentially what's happening. We are only defining the state that we want. It's up to the resources and the local configuration manager to figure out how to make that happen in PowerShell DSC. This makes it much easier to read and much easier to maintain. It's very clear, what's expected. Anyone can read that, and I'm going to show you a fairly complex PowerShell DSC definition once we get to the demos. It's amazing what you can do with this technology, and that's only one thing. There are all sorts of resources out there for you to download. So let's talk about desired state configuration itself. So this is the IAC, the Infrastructure as Code tool, given to us by PowerShell. It uses a declarative model through definitions, although it calls them configurations. Right? It also provides for enforcement of those configurations. So, and the local configuration manager which does that and which also applies those configurations really acts as the engine for all of this. So, think of the local configuration manager or the LCM as the heart. But the resources are the building blocks. So, as I mentioned, the LCM validates state and applies changes specified to bring things in line. And it can enforce previously applied configurations. It can audit, see that there's change, and fix that change. You can actually manipulate this behavior. You can tell the LCM to only validate, or to apply once, or to keep applying. Fix, correct it, apply and correct if there is a difference. But it also, when it's hooked up to a pull server, it can actually check for updates to a definition that should be applied, right? So you go and you update that definition on that pull server. Well, the next time that the server's LCM checks in, it is going to see that, hey, there's a new definition for me. It's going to download that and start processing the change right then. It's going to be really cool. So, whereas the local configuration manager, applies changes, resources are where we define the expected state, right? So you'll find resources, DSC resources like package, which allow you to install Sql patches or other packages and make sure they're on the machine. You'll find resources like the Windows feature resource, which allows you to make sure that a Windows feature is installed and configured a certain way. And these things become the building blocks. Think of them like Legos, right? We're building a Lego staircase to where we want to be. Or really, we're building any sort of thing we can think of in our imaginations. Now, they use a real simple syntax too. They contain attributes that we specify values for. So it will be like attribute equals value. Real simple, straightforward, hard to get confused with. Now, there are a lot of these out there. There are tons of DSC resources, and new ones coming every day. The one in particular we're going to be looking at today is the SQL Server DSC resource module, right? That's going to allow us to install SQL Server, to configure SQL Server, and to set up our availability group. Before we get to that, though, let's talk about the difference between the push versus pull models, right? So what we're going to be doing today in our demo is we are going to be pushing a configuration out. That means we're going to manually go to each system and we're going to say, hey, apply this, right? We're initiating it on each system, right? The reason we're doing it this way is this is the easiest way to demo these concepts, to really show you the technology. Pull servers can get somewhat complicated, especially when we talk about the setup. I wouldn't try, if I were you, to set up a pull server initially. What I would do is I would first get myself acquainted with the concept of the LCM and resources and how to use those. And then once you're ready, you've decided that this is for you, then set yourself up a pull server. I would honestly recommend starting off with the simplest of pull servers, which is a file share. It's an SMB share. Now, pull servers are a central location for storing configurations and the modules, like those DSC resources that you're going to download off the web. This way, when it pushes out a configuration, it can also push out the modules with it. Right? So everything's in one place. You just hook the system up to the pull server and it'll take it from there. Now, in larger environments, if you're really going to use this for production or as a critical part of your development environment, you will want to set up a pull server at that point. This is what allows you not to have to apply the same change onto 15, 20, or 100 or 1,000 different servers manually, right? So this, with a pull server, is an automated process. This is a goal to work towards. All right, so let us dive in. Now, I am actually going to go over to here. Now, this is actually a desired state configuration. So, what we want to do is we want to first note that a configuration is very similar to how we create a function, right? So we've got our block defined by configuration, and in this case, the definition's name is Sql Install, right? This is going to install SQL Server for us. And in fact, I started this a little while ago and let it run. It's actually done now. The reason I did that is because it does take a while. How long exactly it'll take will depend. So, we want to be mindful of that. Now, I've already installed some of these resources. It's just install-module, right? You can see the statements I used up here, these guys. So the SQL Server DSC module and the PS desired state configuration modules, you're definitely going to want those. There are others for working with things like Active Directory. If you want to set dependencies such as, Active Directory this Active Directory account has to exist in AD before you can set up SQL Server. You can do that. You can really go into the weeds with some of this stuff. So we have our initial block. We define configuration and then the name of our configuration, aka definition. I'm going to switch to definition from this point on. All right. So we then import those just like we would PowerShell modules. All right. We list all of those at the top. And then here's where we essentially will create within the node block. We will start, implementing our and listing our resources. Now, node, we could have a separate node block for different systems, right? We could even have multiple node blocks, each handling a subset of systems. This particular configuration is meant to be run on any server whatsoever, right? So I've created a few servers and I've run this. I've actually run it directly on this particular server. So let's look at what it does. First, here's that Windows feature resource I mentioned. Now this comes out of that PS desired state configuration module. I should also note that if you see a module with an X before it, that is, think of that as a beta, right? It's not an official release yet. So you may or may not want to use modules from there. So what we're going to do here is we're specifying that we need to install the .NET Framework 4.5. And that's because we want to install SQL Server. So Windows feature is the resource type. And then we put a name here. We put this name here so that we can reference it and create dependencies later on. Now, each of the Windows features has a specific name for them. This is the one for the .NET Framework 4.5, and we're saying this must be present. In this case, what will happen is if it is not present, it will actually install that feature. And we could even let it reboot if necessary. Now, there is an argument to be made for controlling reboots. Understand that. But if we are building a server and we expect certain things to be on there, I would say that a reboot is okay if it's going to cause issues to not reboot. For example, if you're setting up a failover cluster, well, you're going to want to, right? You're going to want to make sure the failover clustering feature is installed. Now, it does not require a reboot to install that, but some Windows features do. And what happens in a reboot is the LCM, the local configuration manager, is actually smart enough to reboot and then pick up where it left off in the process afterwards. So it'll actually go and complete the work. So you don't need to worry so much if you're deploying a system for the first time about rebooting 3 times during the process. We'll let it do what it needs to do. Now, if you feel like putting in logic there to say don't reboot until this point, that's fine. Now, so what we've got is 2 features, .NET Framework and failover clustering. And then we move into the actual SQL Server install. Now, these are only some of the settings that are available to you. If you search for SQL Server DSC online, you'll find the GitHub repository for this, where you can actually dig into the source code and look at how this thing is built. If you're trying to create custom resources, which you can do, you know, that might be a useful way to see how it's done. So in this case, the SQL setup install default instance, we are specifying an action. In this case, we want it to install SQL Server if it's not there. So what this will do is it will check, hey, is a SQL Server default instance installed? And if it is, great. Does its configuration match what I've got here? If the configuration doesn't match, it will go and it will actually fix that. Now, if its configuration, or if it's not installed at all, it will actually go and install SQL Server. And it will configure it as specified. Now, obviously, I've taken a very bad habit in terms of security, giving all local administrators on the box sysadmin access. But this is a lab environment. I've had to build this thing about 15 times for this presentation. So, here we're setting tempdb file sizes. Source path is one you are going to want to know. That is the path to the SQL Server binaries. Normally, this wouldn't be a drive. It would be a network share somewhere. And the only feature we're installing is the SQL engine itself, and we're saying to make sure that TCP/IP is enabled. We've all run into that situation where TCP/IP doesn't get enabled after we do a SQL install. This makes sure it's enabled. But one of the key things I want to show you here is this depends on attribute. This is how we can set dependencies. So in this case, we can't install SQL Server until we've got the .NET Framework 4.5, because this is SQL Server 2019. So we really want to, we put this depends on attribute here, and it will wait until this guy up here is done. Once SQL Server is installed, we really want to set a specific configuration value. And in this case, max stop of 4, right? So we want a max degree of parallelism with a value of 4. Say this is an 8-core system. So we specify the SQL configuration resource now. And we pass it in the server name. Now you can get the current node name from this variable. There's the node variable. And if I just go here, I will see if IntelliSense pops up for you all. Doesn't want to pop up here. So, but node is an object with properties, right? So you can, use that to get the current name. You could also use the computer name environment variable and fill that in here if this was localhost. Or you could specify any server name you want, and it will try to reach out to that server. It uses the instance name and combines it with this to open a SQL connection. So you can actually, from one server, set a value on another if you like, right? We then pass in the option name, and we use the full name here that you would find under SP configure. And then we specify the value for that option. Finally, we specify whether, as part of this configuration change, if a change is made, if we want to restart SQL Server. So in this case, no, we don't want to restart SQL Server. However, we do want to ensure that SQL Server is installed. So we've got that dependency here. Now we're starting to get into what we need to do for always-on availability groups. Right? Now, personally, I feel like this resource is badly named because always on is a marketing term. Really, this could be better named, but that's my personal preference. So we want to ensure that that is checked, right? So that little box where you go into Configuration Manager and you set it, we want to make sure that that is checked. So we specify the instance name and the server name again. So yes, we can do this remotely. So what I want to show you right now is Sql Logins. So there are another few things that we have to do with desired state config. Because we're going to set up an availability group and we're not using the GUI, we need to make sure that certain logins have the appropriate access. And this is great because it allows us to see the process of adding in, a login. There are going to be certain logins in your environment, maybe one for a monitoring tool, right? And we can make sure that those logins are added to our system appropriately. So we're going to add the cluster service because failover clustering is installed on this machine, and we're going to want to make sure SQL Server allows that in to the instance. Then we're going to assign certain permissions to that cluster service, specifically view server state and alter any availability group. That way the cluster service is able to make changes when it needs to. All right, so we've assured the login, and now we're going to assure that we have the appropriate cluster service permissions. Another thing that we need to do, if you're familiar with this, if you've ever scripted out the creation of an AG in T-SQL, right? We need to make sure we have our endpoints, right? So we're going to specify a type, in this case database mirroring, because that's what is used for availability groups. And we're going to specify HADR as our name. We want to make sure that it exists. If we put absent in anywhere you see ensure equals present, you can put absent and it will make sure it does not exist, meaning it will actually drop that object on you. And we're going to specify a port for the endpoint and the server and instance name again. You can see a lot of these things don't necessarily need to be run from the machine you're actually configuring. I generally try to keep them somewhat close to home though, right? Or separate out concerns, right? I might separate out my availability group definition from my SQL Server installation definition. The other thing that we need is a database, right? And so we create this placeholder database. Its recovery model is full. Its owner is SA, and we make sure it exists, right? This is the database that we're going to use, add to our availability group, and go from there. So, this brings up an interesting topic too. So one of the neat things about PowerShell desired state configuration is if you do need to include some conditional logic or looping, you can do that. It is possible. I would recommend you try to avoid that or keep it very minimal so that you don't add unnecessary complication. But you could create, for example, something, use this resource to get a list of all the databases on your SQL Server and ensure that they're configured to use SA as their owner name. So, once we've got our database, it's time to actually create our availability group. And we're going to have a much more complicated list of dependencies. So, whereas before we've only had one, in this scenario, what we've got here is multiple. So if I go down this list, we need to make sure that HADR is enabled. We need to make sure that we have the appropriate endpoint. And we need to have, the appropriate permissions, and we need to make sure that that placeholder database exists. Once all those tasks are completed, then we're ready to add our availability group, right? So for our, test availability group, we're actually going to we're actually going to use this specific machine that we're logged into as our primary. So we want to assure that that AG is there, and we're actually creating the AG in this statement on that system. So it will create the AG test availability group. It will obviously add itself as a replica. It has to do that. And it will, use synchronous commit for itself. Once that's done, this next block is actually for a secondary, if you will, right? So if we want to add a replica, I actually ran this script on 2 machines and created a 2 replica availability group. So we'll take a quick look at that in a little bit. But when we add a replica, because it's not our first system in our AG, so we're adding our second, we need to do things a little differently. So I set this to pull the computer name environment variable. I set a dependency on a few things, specifically that the AG already existed. Right? Now, we pass in our local server name. This is the one that's going to be configured, server name. And I also have to pass in the availability group name as well as the primary replica server name and instance name. It's actually going to log into this machine, to SQL AG Demo A, to add this replica. So it's going to do that, and then it moves on to this next part where it actually adds that database into the availability group. Now it uses the SQL AG Demo A to create that. This is where it backs up to and where it restores from. I created a share there to allow that to happen. We pass in the database name, and again we pass in the primary server name and instance name. So we ensure that is present in the AG. So we're actually able to use this to define that certain databases need to exist in the AG. I'm going to be honest with you though. Typically when I use this to create an availability group, you know, I feel that the database and the server are separate, right? They're different services. Really, this block of code should be in the same place as the definition for the schema, etc., right? They know which availability groups this database should exist on. But that is a philosophical difference. Again, we're passing in multiple dependencies. But finally, we get to the creation of our listener, right? So we create our AG. Our AG is created, so now we're going to create a listener for it called AG test. And we're going to pass it in the IP address and the subnet address. Now this is the subnet in my home lab, so it might be yours might be different. In fact, it likely will be different, along with the port. Now there is an option to tell this to use DHCP. That's up to you. You may want to do that in your lab, but I prefer to have static IP addresses. So finally, we end our configuration block. And here's the interesting thing, right? I'm just going to put this here to separate this. So once we've defined all of this, we actually have to call that function. And what that's going to do is it's going to create a MOF file, right? You can see it right up here in the top of our output that it created this localhost.mof, right? So when I ran this piece, that's what happened. Now, if we actually want to, tell the local configuration manager, hey, it's time to start configuring yourself and use this this MOF. This is the command we run, right? This is the push model as opposed to the pull model, right? So I ran this already, and I specified verbose because I really wanted to show you kind of what's happening here. So this started to go through, and the first thing it did was it told us that an LCM method call arrived from user with this SID, and here are the steps that it started to take on our local system here, Sql AG demo A. And the first thing it did was it started up the resource for the .NET framework, ran a test to see if it already existed. If not, it installed it, and then it moved to failover clustering, went through the whole process, and then it went through a very long process where it started installing Sql Server. It actually checked for all the features, whether, did we specify them? If we specified them, are they installed? But, outputting this, you might want to output all this to a file, for example. You can see that it did not here detect certain features, but it didn't need to install these features. So then what it did was it actually went out, it installed those features, and it ended up executing this whole statement. This is actually what it passed to the setup program, all the parameters. So, if you use this and you output this to a file somewhere, you can look back at it later. All right, once it finished up with that, it started configuring, our max degree of parallelism, and found out that it was actually in the desired state. So it ended, it skipped, setting the value because it was already where it needed to be, and it moved on. Then we get to our availability group, and this is where things kind of get a little more interesting because, there's a lot that goes on under the hood, as I'm sure you're aware if you've ever manually set up an availability group without using the GUI. So it found that the setting was expected to be enabled, but wasn't, so it went in and actually enabled it for us. So it did have to do a service restart, and so it did that. So did all that, enabled the HADR, right? Added its appropriate permissions, and then started to set up the availability group itself. So we can see here that it's starting to create the AG. It gets the current, it looks for the availability group first, connected as the current user, right? And then check the configuration. So realized that certain things weren't there that should have been. It fixed those, so we can actually see commands that it did in fact run to add those permissions, right? We can see that it changed database context to master, and then we can see that it's actually executed create availability group. And this goes on and on, all right? We get down here and we actually get, and this is nice, right? It gives us a little bit of info into the timing. This is because of the backup that it needs as part of that process. So we're actually getting the outputs that you would get in SSMS doing this. And eventually, it finishes. Now, one thing to note is I did, in my environment, in my lab environment, have a cluster pre-configured. This is because I use separate automation to just bring up a cluster whenever I want in my lab to make it easier, because I create a ton of these things. It also meant that I didn't have to go out and hunt for an IP address for that cluster, and also for that listener. So think of it this way. It's as if the sysadmins handed me the cluster. I just needed to create the availability group. All right, so that's it. I had actually installed the DBA tools module here as well, but I did not do that through DSC. All right, so I have switched over to Management Studio real quick because I wanted to show you that after I ran this on both my VMs as part of this demo, what we have is our AG placeholder DB is in our availability group. That availability group exists. You can see the database in there. And you can see that SQL AG Demo DB is also part of that availability group. So we've gone from, being handed just a failover cluster to having, SQL Server installed, configured, and an AG created, and a database added to that AG. So with that, I really want to thank you all for sticking through all of this. I hope you had a lot of fun. I am really looking forward to the Q&A with you all, which will happen momentarily.